Hello again. So moving to the next question, which is over here, as you can see in front of you, we will talk about question 4, which is determining the concavity of the function using the first and the second derivative. Exercises from 9 to 14, page 276 in your box. So let's see how we can solve this question. So we'll learn how to find the intervals of concavity. Okay, so starting with this question, actually, that's it. You can find it over here, which is this. Okay, that's it. This is my question. So in exercises 9 to 14, find all critical numbers and use the second derivative test to determine the local extrema points. Okay, directly. So as usual, we'll start with polynomial, as you can see, starting with the domain. So the domain for the polynomial, as usual, is R from minus infinity to infinity. So now we have to find the first derivative. So the derivative is 4x to the power 3 plus over here 3 times 4, which is 12x to the power 2. Now we have to make the derivative equal to 0. Now, for this, you can solve it directly or by factorizing by taking the greatest common factor, which is 4x squared. So I can take the 4x squared, or you can use the calculator for doing that as you like. Now, 4x squared outside, that will leave me with, in here I took the 4, and in here I have x only, plus 3 from the 12 if I took the 4, and x squared 1 time. Okay, so equal to 0. So now I have from this x equal to 0, and from this I have 0. Okay, and from this I have x equal to minus 3. Now I will check if they are included or not. The 0 is included, the minus 3 is included. Okay, now let's see. We need to find the critical numbers. So the critical numbers are in here 0 and 3. What about the second derivative test? Now, for the second derivative, I'll start with finding the second derivative. Now, the derivative for this 3 times 4, which is 12x to the power 2. Then, this is going to be plus 24x. Okay. And, of course, in here, you have to make the second derivative equal to 0. So, that will be, so make this equal to 0. Okay. In here, we can take 12x, yes, 12x as a greatest common factor, or you can use the calculator for factorizing that as you like. So 12x outside, that will leave me with x plus 24 over 12, which is 2, and the x in here, we took it outside, equals 0. So that will give me x equals 0 and x equal to minus 2. Now, all I have to do for finding the concavity intervals, now I need to graph the number line. Okay, so this is my number line, let's say. Okay, then I have the values minus 2 and I have 0. All I have to do is just substituting in the second derivative to see the values before minus 2, if these values are negative or positive. So we will see. So in here, I will go directly to the calculator. I'll put the function. So over here, I have 12 alpha x square plus 24 alpha x. Then I will choose calc. Then I will choose a value less than minus 2, let's say minus 3. Okay, so this is positive. What about another value? Between 0 and minus 2, let's choose minus 1. So the first one, it was positive. What about the second one? It's negative. So positive, negative. Then the last one, it will be in here calc at 1. for example. This is positive. So in here we have positive, negative, positive. So I have positive, negative, positive. So that means I have concave up, I have concave down, and I have concave up over here. So I will write now that I have concave up from minus infinity to minus 2, okay, union with from 0 to infinity, and I have concave down from minus 2 to 0. Okay, now for the inflection points, in case you have changing from concave up to down, that means you have concave or you have inflection point, sorry. Okay, so that means at the minus 2 we have in here the changing from concave up to concave down. That means I have inflection point at minus 2, so which is minus 2 and f of minus 2. Be careful, if you'd like to find the point you can substitute in the original one. And I have another inflection point at the 0, because in here we have changing from concave down to concave up, so I have also 0 and f of 0. Okay, now for the second derivative test for finding the local points, I can find f double prime of the critical numbers. So in here, if you remember the rule which says that if you have f double prime of the critical number, if it's greater than 0, that means you have local minimum, which means if it's positive it will be local minimum. If it's less than 0, that means you have local max. Be careful, it's the opposite over here. And if it's equal to 0, go back to f prime. Okay, so in here we have f double prime, f double prime of the critical number, f double prime of 0. Okay, we have to substitute the 0 in the f double prime, so this is going to be equal to 0. So I don't know if it's local maximum or local minimum. They said in here if it's equal to 0, go back to f prime. Now what about the second value, which is f double prime of minus 3? If you substitute the minus 3 over here, so let's see. So that's it. The calculator, still we have the same function. So calc at minus 3, and this is going to give me what? 36. 36, it's positive, which means it's greater than 0. So this is 36. That means I have local minimum at x equal to minus 3. Okay, but what about the 0? So to know if you have local maximum or local minimum at 0, you have to go back to the first derivative test and graph the number line over here. Okay, and put your numbers. I have 0 and I have 0 over here and the minus 3 before the 0. So eraser, I have minus 3 over here. Okay, minus 3. Now we already know that we have local minimum at minus 3, so it will be down, up. So let's test the value after the 0. If we substitute any value after the 0, so let's say if we substitute the value 1, for example, so we will substitute it in the derivative. So 1 for 1 in here, 4 times 1 cubed, it will be 4. Then plus 12 times 1 square, which is also going to be positive. So positive plus positive, it will be positive. So it will be up as well from here. So as you can see, up, then up, that means at 0, it's neither, where's the pen? Okay, that's it. Okay, so for the 0, neither max nor minimum. Okay, so that's it. This is the end of this question. Next, inshallah, we will solve the same question if we have uh, e to the power 5, for example, e to the power minus x, or e to the power x square or minus x square. So we will see that how we can solve the exponential function.